Hi, Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to share about chemistry. This is chapter 7, ionic equilibrium, matriculation, Sem 1. So let's take a look in this question. Figure 1 shows the titration curve for 20 ml of down concentration of sodium hydroxide solution titrates again a solution standard solution of 1 mole of acid, hydrochloric acid. So now from this graph you can see the graph from pH dia tinggi, dia drop turun ke bawah. So basically this graph actually menunjukkan your analyte. Okay, as we aware ataupun kita nampak dalam our experiment. Okay, this is our experiment. Okay, this is our experiment between the acid and also the base. Sorry, my lukisan tak sangatlah memberantangkan. Okay, so we have the titrine and also we have the analyte. And basically, our analyte, we will know the concentration and also the volume, right? So that is the analyte. That is the key untuk you identify which one is analyte and which one is titrine. That's it. And untuk analyte, we will obtain dia from the graph. Maknanya graph ni menunjukkan the analyte. So means our analyte now is sodium hydroxide because dia mula daripada atas, pH dia tinggi. Sodium hydroxide is the best. Best must more than pH dia must more than 7. So automatically our titrine is HCl. That's it. Okay, so now define standard solution, equivalent point and endpoint. So standard solution, if you remember in your experiment, kita isi air tu sampai dia capai remarkable mark ni kan. So that is the standard solution. So what's the meaning of standard solution? Standard solution is the solution with accurately known the concentration. That's it. Okay, that is the meaning of standard solution. And how about the equivalent point? Equivalent point is di mana kita punya acid kan, kita nak titrate, kita nak hasilkan the neutral punya solution. So bila mana kita titrate acid ni ke dalam sodium hydroxide, ada satu point di mana semua acid dan semua sodium hydroxide dah habis bertindak balas. Okay, dah habis pun react with each other. So that is the equivalent point, di mana semua mole of acid dah bertindak balas dengan mole of base punya mole. Okay, so that's it for equivalent point. So apalah kita nak cakap? Point at which mole of acid react with at base, tiba lupa kan, completely. Okay, di mana dia dah complete ke semua mole tu dah react, dah habis dah, maknanya dia neutral. Okay, so that is the equivalent point. So how about the endpoint? Endpoint dia merujuk kepada the indicator. Okay, the indicator. Bila mana you punya analyte ni dia dah berubah warna, means dia dah capai the endpoint. Maksudnya dia dah penuh neutral lah macam tu. Okay, sebab ni kita kena tengok balik lah dia punya range of indicator punya warna tu you baca sendiri lah. Okay, so endpoint di mana the point at which the indicator change color. Okay, itulah maksud dia. Alright, so now wait, I now copy paste this one. Sorry, oops. Okay, so now what is the pH at equivalent point that of the titration? So basically kita punya Z tu di sini, dia di tengah-tengah. Okay, di sini dalam basic, ni dalam acid lah. Maksudnya di tengah-tengah. Bila mana kita cakap dia di tengah-tengah, dia di tengah-tengah ni, tengah-tengah, dia adalah neutral. Okay, and bear in mind, kita buatlah persamaan kimia. When the sodium hydroxide in aqueous will react with hydrochloric acid in aqueous, will produce the most popular salt in the world, which is sodium chloride, and also water in the liquid. So silalah sedar yang bahawa sodium chloride is the neutral salt. Okay, the sodium chloride is the neutral salt. Kenapa dia neutral salt? Because the reaction between the strong acid and the strong base, from the strong acid and strong base, will produce the neutral salt. And how about the between react with, contohlah HCl, the strong acid, will react with ammonia, which is the ammonia is the weak base, so it will produce the acidic salt. Okay, kalau contoh apa lagi contoh, sodium hydroxide, okay, which is the best strong base, akan react dengan ethanoic acid, so it will produce the strong it will produce basic salt. Okay, so that's it. Kita kena tahu lah. So basically, bila dah dicapai this equivalent point, the pH must be neutral. Okay, the pH must be neutral. So kita boleh cakap lah pH 7, and akan produce the neutral salt. That's it. Okay, so moving on the next question. Calculate the molarity of sodium hydroxide solution used in the titration. Okay, by the way, in this question, ramai yang akan guna this formula. M1V1 is equal to M2V2. Tada, salah. Okay, because this is the neutralization. Yang kita guna tadi adalah pencairan. Okay, so tak boleh. Kita kena guna formula MAVA is equals to MBVB A over B. Okay, ataupun you nak kira satu-satu pun boleh, but I suggest you to do like this. But you must do your chemical equation first, then baru you boleh nampak lah macam mana nak buat ni. And in this case, dia punya reaction sangatlah mudah, which is sodium hydroxide dengan HCl. Kadang-kadang soalan tu dia akan bagi yang the complicated punya acid base, or you akan pening and you tak tahu macam mana nak buat the chemical reaction punya equation. So yeah, you kena bersyukur. So first thing first, dia nak apa? The molarity of sodium hydroxide, means you nak cari ni molarity of base. So molarity of acid kita dah tahu, iaitu 1 molar. And the volume of acid untuk kita capai the equivalent point must be 22.5. So that is the requirement untuk kita capai the equivalent point. And MB, we must find the value of MB. And what about the VB? Kita dah tahu, which is 20 mil. 20. Okay. And this is the coefficient of your, according to your equation. Okay. So di sini 1, 1. So, kita boleh tulis 1/1 sama dengan 1 lah. Tak payahlah tulis 1/1 tu kan. Okay. So now, dia akan jadi 20 MB 22.5. So your MB will be 1.125 molar. Okay, so that is our answer for question 3. So moving on the last question, which is calculate the pH of the solution after the addition of 25 ml of hydrochloric acid. So kita dah capai equivalent point. Lepas tu kita tambah lagi sampai kita punya volume 25 punya volume untuk acid. Maksudnya kita titrate acid ni. Okay, ini kita dah dapat sini 20. Lepas tu kita tambah lagi ke dalam this analyte. So basically, kalau kita tengok, ni ramai orang akan pening. Okay. Kan, first, kita punya titration tu kita sampai 20, berapa? 22.5 kan? Okay, 22.5. So, contoh lah kita agak sampai sini. Macam tu. Okay, kita agak 22.12. Sinilah contoh. Okay, 22.5. So means kita akan gunakan this volume untuk kita neutralize. Okay, and then dia cakap dia tambah lagi sampai 25 ml. So means dia sampai sini. So berapa volume yang kita guna sini? Ni yang kita nak cari. Kita tak tahu berapa. So means kita kena tolak. Kan? Kita kena tolak the volume initial, which is 25 minus 22.5. So you will get 25 mil. Okay. So basically, in this question, kita boleh guna M1 V1 is equal to M2 V2. Why? Because saya tambah. Bila kita cakap dia tambah, addition, dia akan melibatkan this equation. Okay, silalah ingat. Okay. So basically, okay, apa M1 kita? Kita nak ambil acid ke kita nak ambil alkali ataupun base? Tu yang ramai yang terconfuse kan? Okay. So basically, kita akan ambil acid. Okay, sebab kita cerita pasal acid. So 1 mol volume dia adalah berapa? Inilah initial 22.5. Kita nak cari M2 dia berapa, and volume akhir dia kan, kalau kita perasan dia tambah ni acid ni ke dalam our this one analyte. So our analyte dia dah awal-awal 20 kan, tak boleh tulis ni. Okay, 20 mil kan. Lepas tu dia tambah lagi sebanyak 25. So kita tambah je lah, 20 tambah 25 kita akan dapat 45. So you will get berapa ni? 45 bahagi 2.5. 2.5 bahagi 45. So M2 0.0556 molar. And dia tak nak tu, dia nak pH. So bila pH is equal to negative log H plus. Silalah ingat bahawasanya ini sama dengan concentration of H plus. Okay, so kita akan dapat negative log 0.0556. Kita akan dapat 1.26. That is our pH. Okay, thank you.